Hello and welcome back to hopefully the last part of IGCSE Organic series. In this video, we discussed about condensation, polymerization, some examples, and basically everything about condensation, polymerization in detail. Let me know if you have any questions and let's start. We know about the term polymerization. Polymerization is a process in which a monomer is converted into a polymer, right? It's a long chain of monomers. And we also studied another type of polymerization, which is addition polymerization. In addition polymerization, a double bond is broken down to form a chain, right? But today we'll discuss about condensation polymerization. So condensation polymerization is also a type of polymerization, MERS. So many monomers form a polymer by removal of water molecule. Water is removed. You might remember when we were making esters what was happening. So we had an alcohol, here we have ethanol, and then we have a carboxylic acid. We have ethanoic acid here. Water molecule was removed and we got ester plus water molecule. So here only one water molecule was removed, right? Just one. But when we're doing condensation polymerization, water molecule is removed after every consecutive monomer. Let's try to do some examples. Okay, so we have two monomers. We have two molecules. The first molecule is, can you name it? So it has 1, 2, 3, 4, 5, 6. It has 6 carbons, so it's hexane. And it has an NH2 group, so we call it amine. But there are two of them, so we will say diamine. And then amine is on the first and the last carbon, so we say 1, 6 diamine. Hexane 1,6-diamine is the name of this monomer. We can also rewrite this as 1,6. There are two different ways to write this. 1,6-diaminohexane. On the other hand, we have it is a carboxylic. It has two carboxylic groups on both sides, so it's called as before that, let's write the carbon. It's a 6 carbon, so it's hexane. And then we have two carboxylic groups, so we don't call it carboxylic acid, we call it dioic acid. Here, I'll take the orange one. Dioic acid. And again, the acid group, the carboxylic acid group is on the first and the sixth carbon, so we will say 1, 6 dioic acid. So these two are the monomers, okay? Monomers which will form our polymer. Now, how do we do it? We have to remove our water molecule. So we remove water molecule here, and one hydrogen there, oxygen, and hydrogen from hexane 1,6-dioic acid, and one hydrogen from 1,6-diaminohexane. Okay, from the other side as well, we have to remove one hydrogen, and over here, water molecule again. So if we try to write our polymer, how is it going to be? I'll copy this. So what happens in the center? We have a nitrogen combined with carbon. This is our H, CONH. On the other side, we have nitrogen and hydrogen again, and an open bond. On the extreme right side, this is how it is. So we'll do this and write N, because this continues over and over until N times, plus we have N water molecules. So how do we name this polymer? The name of this polymer is called as Nylon 6, 6. I've all heard of nylon. It's used in clothing. It's used as a rain-proof jacket. Do you know the strings in tennis rackets? That is also made up of nylon. For example, if they tell us that we can write it as H2N, and then you can see we have a CH2 group. This is CH2 group which is repeated 6 times, right? So we can write CH2 and then write 6 there, and then it has another amine group. Plus, for the dioic acid, we have C double bond OH. So we will write HOOC, and then we have CH2 which is repeated 4 times. 4 times here because the other two are bonded here. 4 times because the other two carbon are bonded to, as a C double bond OH. So CH2 4, and then C double bond OH. Let's try to, okay, before doing condensation polymerization, we can rewrite it, the main groups where the change is happening, and here we'll just make a box. This is very useful when you're doing polymerization. So we'll write the key here. This square means CH26, so you don't have to repeat it over and over again. Plus HOOC, and then we cannot draw the same one, so we'll make some lines. We will call this, this is our key, we'll call this CH2 4. This is attached to COOH. Now again, water molecule is removed. Remember, OH is taken from the carboxylic side, from the dioic acid side, here and here. Let's try to write down our polymer. These are our monomers, and our polymer would be NH, and then here, and then NHC double bond O, then another box, C double bond O, and then so on, plus NH2O. Now I want you to know this thing, that CONH, this is which is in nylon, is called as amide linkage. Okay, this is amide linkage, which is important. You can be asked about it, or to write down what is an amide linkage. It's C double bond O and H. Okay, a question. Nylon is said to be a polyamide. Why? If you try to think of the answer, I think the answer is kind of said in the question. It says poly and it says amide. It has poly, right? It's made up by condensation polymerization, and it has so many amide linkages in it. That's why nylon is known as a polyamide. Okay, and now we'll look at a second example of a polymer which is made by condensation polymerization. This is known as terylene. So what are the monomers of terylene? First, it has ethane, 1,2-diol. Can you try to write it? Draw it on your own first. Okay, so ethane, that means it has 2 carbons, right? And then ol comes from the term alcohol, and it is diol, that means it has 2 alcohol group, 1 and 2, so it's on 2 different carbons, carbon 1 and carbon 2. So we'll write OH here and OH here. Remember, oxygen is the one that's bonded to carbon, not hydrogen. You cannot write this as OH, okay? Because that shows that hydrogen is bonded to carbon. It's actually oxygen, OH. Okay, what is the second monomer? The second monomer is benzene. You might know it. Benzene is a ring of carbon structure. 1,4-dioic acid. So benzene is a ring of carbon that has 6 carbons, okay? And there's alternative double bond between carbons. So let's try to write 6 carbons. 1, 2, 4, 5, 6. And then there's alternative carbons have a double bond. The rest have single bonds like these. Okay, they're saying first carbon and fourth carbon has a dioic acid. So we'll add, let's say this is the first acid, carbon 1 has C double bond OH, and then this is 1, 2, 3, 4. Fourth carbon has another acid. So rest of the carbons will have hydrogen. Okay, so these are the two monomers. Let's try to write it down in the equation form. So first, ethane 1,2-diol. We'll write this as plus benzene 1,4-dioic acid. Usually it's going to be C6H6 for benzene, just benzene, but this is 1,4-dioic acid. And then C double bond OH. So condensation polymerization occurs. Just remove the water molecule. Remember, every time oxygen is removed from C double bond OH, and from OH group, from hydroxyl group, only hydrogen is removed. Repeat on the both sides, and what do we get? Then it continues, plus N water molecules. Now in nylon we studied about amide linkage. What about in terylene? We have an ester link. So we can say that terylene has an ester link and an O. It's an important thing to remember. And a nylon has an amide linkage H. That is for nylon. We can also write this as, so this is the structure of terylene. We'll label our key. It's important to label it. Alright, so our third polymer is, our third example is going to be glucose. So we have multiple glucose monomers here. Let's remove our water molecule. So we removed H2O. So now we'll remove another one. Notice that we removed hydrogen here. So from here we have to remove oxygen as well as hydrogen to remove one water molecule per glucose molecule. Okay, so in the third one, we removed one hydrogen. So from the other side, we have to remove OH. And then coming back to the first glucose molecule, we only have to remove hydrogen. Let's try to write it down now. O, C6H10O4, and then O, and then C6H10O4, and then O, and then continues. So we can write this as, we can write this as O, and then make a box over and over again. Our key would be, this box means C6H10O4. So that's our key. So we can say that glucose molecules on condensation polymerization forms a starch. Remember, starch is a complex carbohydrate. Remember that in plants, glucose is stored as starch. It's complex hydrate. It doesn't dissolve, so it's easier to store as starch. This starch is made up of so many glucose molecules. Okay, moving on, we will another example is proteins. Now we all know proteins is made up of amino acids. Okay, so different combination of different amino acids form different proteins, and there are approximately 20 amino acids. You don't need to know them, all of them, or even like know them, but you need to know the general formula for proteins. So one example, one amino acid is called as glycine. What is its formula? It's H2NCH2COOH. The common name is glycine, but if we name it according to its formula, it would be, can you name it? It would be 2-amino ethanoic acid. This is called as glycine. Let's see what happens when you have two glycine molecules. So we have H2N CH2 C double bond OH plus another another one of this, but this polymerize. That means water molecule is removed. So we remove water molecule here, one hydrogen here, then OH. From there, let's try to write our polymer, double bond O. Okay, now this was example 1. Now let's do another example with, for example, if we have alanine molecules. And remember, the important thing is that you can do the condensation polymerization, not memorize these formulas. Okay, so let's see if we have two alanine molecules. We have NH2N, CH, CH3, and then C double bond OH. Two of them, so we'll just double this. And I want you guys to do it first. Okay, so I'll do it now. Remove your water molecules, and then one hydrogen here, OH here. So this would be written as the double bond O. Alright, so we performed condensation polymerization on two different types of amino acids. So what can we identify? We can see that we have amide linkages, right? CONH, CONH. Amide linkage in the proteins, they remain same. However, all the the change occurs at carbon atoms. So we can say, okay, now what happens if we want to break down the protein? So if we break down protein, that means do the process of hydrolysis, we get amino acid. So hydrolysis on proteins give us amino acid. Actually, this is true for any type of polymer which is made by condensation polymer. If we do hydrolysis, that means we add H plus and OH, water, we get the monomers. One more point. If we want to identify the amino acid, we can apply chromatography. Chromatography is performed, and if you want to, because they are going to be invisible, so we apply a locating agent. Okay, next, we studied about different types of polymers which were made by condensation polymer. So let's try to find the differences between two of them, which is nylon and protein. First, we can say nylon is a synthetic polymer, while protein is a natural macromolecule. This occurs in nature. Next, nylon has only two monomers only, many monomers. So what are the monomers of nylon? As I just mentioned, diamine and a dicarboxylic acid, while the monomers of protein are amino acids. If we want to know the similarity of both of them, is that both of them have an amide linkage. Now, one more thing I want to discuss about protein is, let's write the general structure of protein. So let's go up and look at our examples. So we can see that here it has an amide linkage, right? And then it has its carbon. It could be different for every protein. This is how the chain goes. So we can write it like this: NH, and then we have one set of carbon molecules, and then we have our amide linkage, CONH. Depending on the type of protein, we may have another, could be same, could be different type, and then it goes again. Now it could be repeated, or we can even have another type of carbon, like set of carbon molecules, and then this goes on and on. These are your amide linkages. So that was the general structure of a protein. Now if we want to draw the general structure of an amino acid, we will write a carbon atom which has a hydrogen. The other side is attached to an R group. It is different for each amino acid, alright? But the amine group, NH2, and the carboxylic acid group, C double bond OH, is same. And this is the general structure of an amino acid.